he says. So think about what all three terms could be divisible by. And then we want to write out what would be left. So we're going to think about 3x times what? X squared would give us 3x cubed back. 3x times what gives you negative 6? X squared. 2. How many x's? 1. See, x times x is x squared. 3x times what?
3.
Minus or plus? Any x's?
No.
Then we have, essentially we have two factors. We have 3x that we're going to set to 0. And then we have what's in parentheses that gets set to 0. Give her a minute to write down. Okay, write down the next line, okay? So if 3x equals 0, what do you think x would equal? 3 times what gives you 0? 0. So x is 0. Or you could think about dividing by 3. Then over here, now we're back to quadratics that we did last unit. We can diamond. So what would multiply for negative 3 but add for negative 2? What do you mean? Okay, wait a minute. I got two questions. Well, I'm going to try to, but I can't do it like an algebra 1 problem because I have x squared. No, I can't just square root everything because I don't have just a number. I've got 3 terms. Okay, now what did you say now? Negative 3 and 1. Okay, so we have x plus 1 and x minus 3. Set each factor and solve to make it equal 0. All right, so we have this one. X plus 1 is 0. X minus 3 is 0. Subtract 1. Add 3. How many answers are there? There are 3 answers. And look at the degree of our polynomial. Our degree was also 3. So we've got them all taken care of. How many are real? All of them. All of them are real. 0's real. Negative 1's real. 3 is real. Any imaginaries? No, there's no i's, right? Okay. All right, let's try another one. Any questions so far? So we GCF, we factor, and then we have to factor again. Right? Yes.
When you do the diamond, how do you put negative 3 on top of the long column?
It's the last number goes what multiplies, and then what adds to the middle. Yeah. All right, let's look at the next one. All right, so step 1, we need it to equal 0 before we start. So how can we make this one equal 0? There we go. Subtract 7x. So we have 2x cubed plus 5x squared minus 7x equals 0. Also notice that I'm making sure that my exponents go down by 1 each time. Okay, I do want my exponents in order to factor. All right, does this one have a GCF? Oh, some people say no, you say An x. Yeah, it does have an x in common. We could divide all three terms by an x. So now we would have x times what? So we're going to set each factor to 0. And yes, this x out in front does count as a factor. Then what's in parentheses counts as a factor. So there's one answer. How many answers are we supposed to get in this problem? How do you know it's supposed to be 3? Right, the degree is 3, the highest exponent. All right, now we could factor this, but notice that a is not 1. So we could either rainbow, if you'd like to do that, or we can do the quadratic formula. Which one would you guys prefer to do? You'd rather do, raise your hand if you'd rather do quadratic formula. So 3, 4, 5, 6, 7. Who'd rather factor? 1, 2, 3, 4, 5, 6. It's like a tie. That means I'm going to do both.
Someone else just raised.
You'd rather factor? Or quadratic formula? And see, now I don't know what we're doing. You'd rather factor. Okay, we'll factor. All right. All right, we'll factor. All right, a is not 1, so we're going to have to rainbow. 2 times negative 7's 14, negative 14. And add to be 5. Okay, and one of them's going to have to be negative. Yep. So we're going to have x minus 2x. I can't remember what I wrote down. Oh, 7. And because a is not a 1, we have to divide by a. That's a 2. Of negative 1?
Yeah.
It's I, plus or minus I. Okay, so we have x minus 2 divided by 2 is 1. This one doesn't really reduce, so I could go ahead and just write x plus 7 halves equals 0 and solve them individually. Because a was not 1. There was a number in front of the square term. This 2. Right, you don't have to rainbow. You can just look at the 2 numbers. Okay. Because a is not 1. So I have to divide it by a. Okay. If you do the quadratic formula, we should have gotten the same thing. All right? Do you want me to go through that? Not today? Okay, not today. You could have done the quadratic formula like we did yesterday, okay? All right, let's try one more. I'll tell you what, we'll do the quadratic formula on this next one, okay? For those quadratic formula folks. One more. We got one more. It did have 3. All right, last one. Yes, they all have an x squared. So Brandon, if we pull out the x squared, oh, where's my pen? What would be the first term in the parentheses?
Oh, you're asking me?
I am. Why not?
Wait, ask me,
Think about it.
Wait, ask the question again.
Okay, x squared times what gives me 2x to the 4?
No. One.
Okay, almost. They're just going to have an x in it. So it's like 1 times what gives me 2?
Oh, 2.
2. Okay. X squared times what gives me x to the 4th? Sure, I want you to finish.
Ah. Okay, come back.
What's the exponent on here?
Square.
There we go. See, I knew you knew it. X squared times what gives you negative 5x cubed? Somebody else.
Me.
Brendan.
5x.
Is it positive or negative?
Negative.
All right. Yes. I wrote that to kind of help. We don't need it. But. All right. X squared times what gives us a negative 3x squared? All right. Take each factor set to 0. Come on, pen.
Is that what you're square? Are you not taking out the square?
I'm going to have to. You're right. I'm going to have to. So how would I take care of that? What would x equal? By square root 0. 0. And we actually get that twice because this technically would be plus and minus 0, but 0 can't be positive nor negative. All right. So that one has 2 answers, and since they're identical, that gives us a multiplicity. There's a balance happening that's 0. Okay, let's look at this other part. Let's use quadratic formula this time. We're going to do quadratic formula, so we get 0, 0, 3, and a negative 1/2. So there's our 4 answers. Even though the 0 is a multiplicity, we're only going to have 3 x-intercepts, but 4 answers. Okay. All right, so in this last few minutes here, I do have an exit slip for you. You've already picked up your homework off the stand over here. The homework tonight, guys, is a little bit of a combination of what we did today, what we did yesterday, and then the first 3 is what we've been doing all along, taking each factor and setting it to 0. Today and yesterday is our exit slip.